Okay, taking the inverse of graphs. Okay, it's a pretty simple concept. All you got to do is look at the original graph and just choose some points on there. So the points on here, -3, -7, -2, -5, 0, -1, 1, 1, and 3, 5. Okay, once you got some points chosen, make the inverse table. So you just swap them around. Okay, and then let's look at these tables. So this table, the original table, that's a function. The second table is also a function. Okay, and what you're going to show on the graph is that line functions, when you take their inverse, they always become other functions. So when you have a linear function and you take its inverse, it will be a function still. Okay, and it's because it's a line, so lines are lines. So let's go ahead and graph this inverse table. So we got -7, -3, 1, 2, 3. We have a -5, -2, something like that. -1, 0. Okay, then 1, 1. There's that pivot point, and then 5, 3, 3, 4, 5, 1, 2, 3. Okay, and you can kind of see your line go like off that way. Okay, one thing to note is that this line here that I am drawing, that is dotted, this is your parent function y equals x, and all inverses reflect about that line. So if you look at points, notice that they are equal distance from that line because they're reflected about there. So every function reflects about that line. On the quadratic, same principle here. So pick some points on there. So I got a -3, 5. -2, 0, 0, -3, 2, 0, and I think I just went left to right. Okay, looking at this table, this is a function. No repeating x values. When I take the inverse of this, 5, -3, 0, -2, -3, 0, 0, 2, 5, 3. We have repeating zeros and repeating 5s. So this is not a function, something called a relation. Okay, so not a function. All right, and that's because when we start plotting this, you'll see why it doesn't become a function. Let's go ahead and plot. So we got a 5, -3, 3, 4, 5, 1, 2, 3, right there. 0, -2, -3, 0. Okay. 0, 2, 5, 1, 2, 3, right there. So you can see a quadratic kind of does this thing. Okay. All right, so that is not a function. It's something that we call a vertical line test. That if you put a vertical line through a function, and we can see that it hits there and it hits there. If it hits more than one place, that graph is not a function. We can look at our linear functions. We put a vertical line test. It only hits exactly one spot, and I can put that vertical line anywhere on there and only hit one spot. But in this one, the sideways parabola, it will not work. Okay. Also keep in mind your line of reflection for inverses. So y equals x, linear parent function. And again, you can see the points are equal distance either side of that line of reflection.